birthday party with 10 more
Come
students.
on, Mir. Hurry up, we're waiting for you. What took you so long? Oh, how long did it take to blend that? 10 minutes?
Not taking the laptop.
Yeah. Oh, come on, be strong. Look, she was up at 2 o'clock and look how much energy she has.
Yeah. Tell him what to eat. She was eating chicken and I don't know what. Something with the chicken.
Chicken wing.
Oh.
And jam sandwich.
Yeah.
Yeah, and sugar tea.
And apple, banana.
So obviously she was.
And wait.
This is the first thing I'm having in the
potato.
whole day.
Potatoes. You have a big appetite.
Too much.
This is probably Iad's first meal of the day. Is it? Yeah, you see.
So.
She's already on number 4, isn't it? We had breakfast, brunch, lunch.
That's supper.
Supper will be soon, yeah. And then of course tea time before bed. Yeah.
Yeah,
Of course, yeah. What do you have before bed? Some toast?
tea and some cookie.
A cookie and tea. Yeah, nice. Yeah. Before bed. And then,
Chocolate cookie.
yeah, just to help you relax. Yeah. Well, I'm sure your parents will be happy to know you're not going to starve. They don't have to worry about you going hungry. That's good. Yeah. Okay.
I'm fat.
I don't think you're fat yet. It's
no,
okay.
I'm fat than the first day I came here.
You're fatter than before. Alright, okay. Don't worry, I think you're still pretty small. It's okay. Alright, can we open up LibreOffice if you have LibreOffice? Or Excel if you have Excel, but LibreOffice, since it can all be the same. Yeah? Yes? Yeah? Now, earlier I was talking about calculating uncertainty, and right now we're going to learn how to calculate the uncertainty for a slope. You got that? Yeah? Now, just before I start, did Lorraine tell you, or not Lorraine, who did the uncertainty with you? Was it Lorraine? Yeah. You know you have, if you have something like A equals, no, I'll use the same one that you did in class. What was it? N equals CV, was it?
Yeah.
Or, if N equals C over V, the formula is the same. It doesn't matter if you're multiplying or adding. In fact, if you had N equals C plus V, or even N equals C minus V, you can use the same formula to calculate the uncertainty. Yeah. Now, in real life and at university, it's not really the same formula. It's so close to being really accurate. We just use the same formula. But just so you know, it isn't really the same formula. But like I said, it's so close, it's easy just to use the same formula for all 4 situations. Okay? Okay, good. So, what we'll do is we'll type in some numbers, and then I would like you to type in the same numbers so we can all do this together. So, we'll put in 10 x's and 10 y's. So we'll say 0, 0.15, 0.31, 0.44, 0.62, 0.75, 0.91, 1.03, 1.2, 1.21, and then we'll say 1.31. And then we'll put in some y values. 0.1, 0.31, 0.62, 0.8, 1.2, 1.51, 1.88, 2.01, 2.4, 2.59. So I make this a little bit bigger since it's kind of a bit small.
Where do you get those numbers?
My mind. Okay. Got that? Yep. So, firstly we should do a graph, but you know how to do a graph. Just highlight the data and pick insert, where's it gone, chart. No, I've made it too big. The graph you want is called scatter. Now, my graph, we'll call it, and the x is x in x units, and the y is, we'll call it y in y units. And I've made it too big, so let me just zoom out. Okay, so that's my graph, which I'm going to delete in a moment. There's one thing that's missing from my graph. What have I not put on my graph?
Line.
Yes. So I left click and then right click my dots and pick insert trend line. I also like to click this button and this button. It gives me the equation of the line, which is very useful, and something else which I'll talk about. So right now I have a bit small, but this is what I have. So were you able to do this? Whoops. Were you able to do the same thing?
Yes.
Yeah, great. I'm going to delete this graph to make space, but this is the type of graph I should see in your lab report. Not very difficult to do. You get marks for, please note, you get marks for the x and the x units, the y and the y units, the title, the formula, and the line and the points. So in other words, okay, this graph wouldn't get full marks because the title is silly, my graph, but everything is on the graph that I need.
What's R squared?
That's something I'll explain later. I just put on the graph for the moment. Can I delete this graph now? Yep. Okay. What you need? Delete.
Yeah.
Show him if he needs help. Cut, yeah.
Yes.
Can I continue?
1 second.
Okay.
How can we add the line?
Left click and then right click one of the dots and pick insert trend line. Yeah.
Do you have this video in?
It's recording and will be uploaded later. Okay, can I continue? So, I want to calculate the slope of this line. Very easy to do in Excel. Let me just put it here. I'll write it here. M is, and you type equals slope bracket, highlight the y's, comma, highlight the x's, close bracket. And I get this number.
What size is the example?
Oh, please, I don't have much time because you're getting frappuccinos. Equals slope bracket, highlight the y's, comma, highlight the x's, close bracket. Got it?
This is numbers like
What did you get?
B2, B11, A2, A11.
What? One moment, please.
After the
Thank you, Iyad.
after the
I didn't
bracket,
understand what was going on.
yeah,
Yes?
after the bracket, like I highlight the y. How will I like move it to the equation?
Listen carefully.
Yeah,
Last time that I'm going on. Equals
yeah.
SLOPE, open bracket. Take my mouse, highlight the y's, release the mouse, press comma, highlight the x's, release the mouse, and close bracket. Enter.
Why is error?
Masha.
Why is my error?
Okay, finally.
Alright, I need to go on. You're not even supposed to be here, so I'm just going to ignore you. Right, the C.
Three.
No.
C equals intercept, open bracket, highlight the y's, comma, highlight the x's, close bracket, and enter. It's the same as slope, except the word intercept instead of slope.
How can you write it?
There you go. INT or CEPT. It's a function built into Excel, yeah. So Excel can calculate the slope and the C-intercept for you automatically, which is very, very, very convenient and much more accurate than trying to draw it. Yeah? Okay. Now, can I continue?
Yes.
Yes, great. So, we remember we have the formula that uncertainty of x is equal to the difference between the x average and the x data. In fact, it's the same because it just changes the sign and I make it positive anyway. But if I wrote it the other way, I'll stick to that. Like this. And then you add them all up and divide by how many you have. N. Yeah. 10 in this case here. Now, it's a little bit different here. Please listen carefully. Here we have a line. And let's say here's our points. It's not the difference between the data and the average for these problems. It's the difference between the data and the line. So it's these distances here. Okay? Now the way to calculate those, it's not too difficult, but it's like this. Let's say, for example, this is, let's just say x1, for example. And this here is the line, and we want this distance, for example. Or if we do it with the y's first, maybe that's a bit easier. Let's say this is the y1 and this is the line. So we want this height. So it's the height. So that's the difference between the line minus y1. Now what's the formula for a line, the equation of a line? mx plus c minus y1. Do you know the m? You do. Do you know the x? You could know it from your data. Do you know the c? Yeah, and the y1? You'll know.
What's the C?
The intercept, which we know as well. So what we need to do is make a column here, and this one's called, this one I'll just call it, the technical name for it is y residual. It's just the technical name for it. So the formula is m. Now, the m is 1.953, yes? Times, what's next? X. Now look, the X is right here, so look, I should click it to make it appear. Plus C, and what's the C? 0.0276. And then what's the last part? Minus, which is here, click. Now, I'm also missing these lines to make them positive. So what I do to finish, if you look here, I'll just put brackets around this and write in front ABS, and this makes it positive. If it's negative, it'll be positive. If it's positive, it doesn't do anything. Right, what number did you get for the first one? 0.07. Good. What I can do is, look, I can grab the corner. What? Did you type in exactly this?
Yeah, but without y,
That's the only difference?
yeah.
I must have typed something wrong, Sharif. I need to continue. I'm sorry. Now, if you click this, you can grab the corner and pull it down to copy the formula. You should have something that looks like this. They can be a little bit different. Now tell me, did you type it like this with the 1.953? That doesn't work, because what happens is these get moved. Now I can show you how to fix that. Oh yeah. If you want to easily fix that, so you probably have here something like D2. So just change that into $D $2. And likewise for the C. And then copy it down.
Yeah.
Use the dollar or
Nothing.
no?
Just,
You got these?
yes.
Okay. Can I continue? Yeah.
Oh, yeah.
Now look. Is it working now yet? And Sharif, is it working? Okay. Well, the next part now is with the X. So with the X, let's say here is X, and let's say here is X1, and we want this distance. Then it would be X minus X1. Now remember, we have Y equals mx plus c. So Y minus c equals mx. So 1 over m times y minus c over m, that equals x. So it's like what we did a moment ago, but we have to rewrite the formula to get x instead of y, because we're looking at the horizontal. Does that make sense or not?
It was like y minus y1 is x minus x1.
Yeah. So we need a formula for x.
Yeah.
So we have to rearrange this formula. Yeah. So now we have 1 over m y, which we know, minus c over m, which we can know. That's minus x1. So I'll type that in, and we'll make a new column called the x residual. So what did I start with? 1 over m. So that equals bracket 1 over 1.953 m. Next is times y times click. Next is minus c over m minus 0.0276 over m, which is 1.953. And then lastly minus x minus click the x. Now, one thing I left out, what did I miss here?
Bracket.
The brackets, the ABS brackets. So that's ABS and here. And I can put more brackets in just to prevent any problems. So bracket here and then bracket here. So I have this now. Just that's the formula I have. So this is 1 over m y minus c over m minus x. Don't worry, I'll put the video up so you can type exactly what I type. Got it? Okay.
And then maybe it's like
And enter. And you should have this number. Okay. Can I continue, please? Yes?
Yeah.
Yeah? Okay, let me just scooch this out of the way. Okay. Right, so the last thing here is, what would we normally like to do with the x data here? I think we should get the average. So, you can do that in Excel easily with the average function here. So the average value of x was 0.673. If I copy this over here, what's the next one? Average y. Now, who can tell me what this next one means? What's this average mean? Yeah, so what is the meaning of this one? This is the uncertainty for the y. This is this formula. Add them up and divide by 10. So this is the uncertainty for the y. What's this one here? Uncertainty for the x. So now we need finally the uncertainty for the slope, which is really what we care about. So any guesses on how we could work out the uncertainty of the slope, if you were to have a guess?
The same formula, this one?
No, no.
Y over X.
Almost, Ms. Sharif. Good job. It's the uncertainty of y over the uncertainty of x over 10, because there's 10 points. And that comes out at 0.195. Did you get that too? It's the y over the x over the 10. You'll definitely need brackets.
now how C13, D13.
Yes? So what does that mean? That means my slope is 1.95 plus or minus 0.19. So what you've done is you've said, in this example here, the slope is 1.95 plus or minus, what did I get? 0.195. Like this, for example. Which is, how else? Who's saying how? Oh wow, yeah. Now, we don't often use the slope, we often need to use 1 over the slope. Yeah, so let's say, what was it for Newton? Mass equals 1 over m. So, in this example, mass would be 1 over 1.95, which is, what's that one here? 1 divided by 1.95 That's equal to 0.513 kilograms.
Then what?
But now we want to get the uncertainty of the mass. We have to use our formula from earlier, because it would be uncertainty over the mass over the average mass equals square root. The 1 doesn't have any uncertainty because it's always a 1 in the formula, so that's like 0 here. There's no uncertainty. Plus the uncertainty of m over m squared. Now, the uncertainty of the mass over 0.513 equals square root 195 over 1.95. Is that it? Yeah. So I can calculate the uncertainty of the mass. It's equal to 0.0513. So you would say, finally, the mass equals 0.513 plus or minus 0.0513 kilograms. So not only have you predicted the mass, you've also said that, okay, it's not going to be exactly this, but it'll be somewhere near it by this much, plus or minus. Then what you can do is you can check this with the measurement that you made, with the spring balance, and it should be within these two numbers. Your true answer should be, when you measure it, somewhere between this, but bigger than the lower one here, the two ends, the plus and the minus ends. Yeah? Question?
In our calculations for the physical square,
Yeah.
we will find the certainty only for the mass, or for the...
No, because we got the uncertainty for x and y here. So in newtons, what's on the x? Yes. And on the y? A. So in your report you can mention these, but these you don't really care about. It's the m that you care about, the slope.
What can I mention? The F?
You have to explain in your analysis the calculation of this here. So in order to explain this, you're going to have to say, using these numbers, you're going to have to say, using this formula, you have to show how to get to this box. Now, a lot of it you can do in Excel. In fact, most of it you can do in Excel. So, all I really need you to say in the report is the explanation of what these are. So how would you describe this in simple English?
Y, the difference between the y line, the line and the y?
Vertically,
Yeah.
between the data and the line.
Yeah.
And so what would this be?
The average of the distance.
The average of the difference between the data and the line vertically.
And then
And this is the average in the difference in the line and the data horizontally. And then the slope is the average, because you're dividing by 10.
Of the average?
No, the average of the ratio of the uncertainty in the y to the x. Yeah? It's tricky, but this is my plan. We have physics again this week, don't we? When? Thursday? And do we have
Can you
another?
come back to another table?
Here?
Yeah. Y the average mass is equal 0.513.
1 over 1.95.
But this is the average, not the average mass, not the mass.
It's the same thing. Remember earlier, Musharif, I said when you use the slope to get a number, it's like an average because you're taking all the points to produce 1.
So the thing we did after the finding the mass after that box. Is it necessary to do it? It's showing the uncertainty, or it's just
Which thing? This?
after the box? Yeah, this thing. Yeah.
Oh yeah, because you need to calculate this, which goes back in here in the answer. That's where this came from here, this formula. No?
Okay.
Yes.
What's the full formula for that? Like
Oh,
that
you,
put zero.
you did this with me and with Lorraine.
Oh, okay.
Come here. You're killing me here.
So that's in the analysis.
No, listen, please, stop, you Sheree, please. Have mercy on me, please.
Yeah.
All I've shown you is something, I've just shown you something which you haven't learned before. That's why I did this, because nobody did this in maths or high school or whatever, okay? And you're using Excel, yeah? Next class, we'll have a look at how the report should be structured, what sections I need, okay? A big section will be the analysis, okay? But another big section will be the planning, yeah? And, we'll have a look at what sections you need to do and how the marks are awarded for each section, yes? But I'm just showing you this because you haven't seen it before. It's new to you.
What are you going to name the video?
I think I'll just call it Physics Lab 1 and Physics Lab 2 or something. Physics Lab Tutorial 1 and Lab Tutorial 2. Now, how many more physics classes do we have this week? Because after this week, I'm not going to give any more time to labs. We're going to go back to the classes.
We have physics on Thursday.
And Friday?
Then 1 hour, and physics on Friday.
Yeah, 4 hours.
4 hours left.
Yeah.
And are they 2-2 or are they split?
1 on the same day.
1-1 and 2.
Without the switching to whatever.
Yeah, so
We don't know about that.
in one class, I'll show you what's required at the lab. In the next class, I'll let you work on the lab. And then, come Friday, it'll be your choice. You can either continue with the semester if you feel like you're ready to, or we can have more time on the lab report. I don't know what your week is like. Is it a busy week?
Next week?
This week. After today.
Just nothing.
Right now?
Yeah, like tomorrow.
Oh, tomorrow. Tomorrow we finish. I mean, we have break, so we finish the Friday.
Come on. Let me put it this way. Do you feel like you would have time in the evening to work on your lab report, or would you like some more class time to work on it? To type it, I mean.
No, I think
You keep your opinion to yourself, miss.
I think it's better to work on it in the evening
Yeah?
than in class, yes.
So, will we return back to this material then this Friday?
I mean, we haven't started, so that puts
But
us in-
No, it doesn't, because there's actually less content to cover in semester 2, because part of the reason semester 1 was so tense was because of the mechanics.
yeah.
Mechanics was ginormous, but there's no topic like mechanics in semester 2. We have materials, we have fields, and we have atoms. And atoms, you already do some atoms with Lorraine. You already know about things like protons and electrons. So the semester 2, the materials and the atoms are quite easy. It's only the fields that's a little bit difficult. Here, this Friday we will start materials. Thursday, please bring your laptop,
Okay.
because one second. On Thursday, the first hour will be what you need to write in the lab report. I'll give you the outline, and then in the second hour you can spend some time working on it. Then the only time you will have to work on your lab report after that will be in ESAP. Okay? So for me, that's it for lab report. I'm not giving it any more time in class. If you have questions, you can come see me and email me. But you can send drafts. I encourage you to send drafts. I love when you send me drafts and I can give you feedback and send it back to you. But that's only if I get drafts.
How many?
Unlimited. Yeah. You send me a draft, I give you feedback, you make changes, send it back to me. It's unlimited.